Hello everybody, welcome back to Archangel RC. I will be taking you into some new territory today because I have finally decided to dip my toes into VTOL stuff, and because I don't like complications too much, I decided to start with the simplest possible way of doing it. A tail-seater wing model that can take off and land vertically. And luckily for me, ArkBird just happens to have one such model designed for that exact purpose, and unimaginatively, its name is VTOL. Apparently, they also have a flight controller that supports such flight, but I will not be using it, but rather would trust that task to a Matek F765 Wing controller running ArduPlane. Usually large-scale VTOL models include either hauling around 3 or 4 motors and ESCs, which deal with the VTOL part only and remain powered off throughout the rest of the flight, so you're just carrying a lot of dead weight around for most of it, just so you can take off and land in rough terrain that is not very suitable to a rolling landing, which is okay if the situation requires it and you have no other option, but it is far from the most efficient use of your resources. Another option is to have the front 2 motors swing forward after takeoff and transition the plane to forward flight, but that requires an intricate design of a motor mount on a servo or some sort of gearing, which is added complexity and might not really be needed, and adds more stuff that can break. And the forces involved in these pivot points are no joke either. The beauty of a tail-seater configuration is that you have a pretty standard plane, 2 tractor motors, 2 ESCs, and in this case 2 servos for those control surfaces, since it is a flying wing, and no additional moving parts on the plane. Basically, the autopilot on takeoff and landing will be keeping the plane's nose pointed towards the sky, tail to the ground, all on its own, using a mixture of differential motor thrust, where it would vary the RPM on both motors independently, as well as the control surfaces to keep the plane in that orientation. The drawback of this setup, however, is that if there is wind, things get a good deal wobbly and shaky until you transition or land. Once you switch over to a forward flight mode, it will do a transition from VTOL state to regular plane orientation, and from this point on you will be flying a plane until the time comes for a landing, when all of this will happen in reverse. But let's get back to the plane itself. At some point I actually came across this on Banggood purely by chance and was not aware that it is actually a second version of this plane. Apparently ArkBird have been at this for a while, because there is a previous model which you can see on their website, and there are a few videos on YouTube of it, though I'm guessing it wasn't overly popular back then. I liked the idea of a simple VTOL, so picked one up to try it out. One of the main issues I have with it was the lack of a user manual for this model specifically, although the plane is pretty much identical in size and compartment arrangement as the first version, so I did go off of that manual, since even on their website they don't have an up-to-date one. There is another really weird thing, especially for a model like this. Take a good long look at this photo, really carefully. Pause the video if you have to. Note the sun is in the background shining through the foam, and see if you can find the problem, and just write it in the comments below before moving on with the video, and let's see how many people are going to see it. So for those of you that got it correct, yes, that is right. For those of you that didn't get it, the plane does not have any sort of spar anywhere in it. No form of reinforcement, so basically the whole thing is relying on the strength of the foam to stay in one piece, especially during sudden direction changes at speed, which occur often when you transition from forward flight to VTOL mode, which can put very high loads on the wings, but we will see how this is going to do in the long run. One benefit of this inherent flexibility is that should you botch a transition or a landing in plane mode, or do not have any battery left to do a vertical landing, you can just drop it on the ground flat. It will flex around, but there will be no damage to the foam. So I guess some good does come out of it. But seriously, no user manual, no information about CG location, no spars or reinforcements anywhere on the plane. I mean, the lack of proper control surface hinges were the least of this plane's problems, and I hadn't even started putting it together yet. Good news is, design-wise, this was definitely made with VTOL in mind due to the huge fins, which are also acting as the stand when it's set up right on the ground. They look weird when landing as a plane, but make a lot of sense for a VTOL and have a good footprint on the ground for some added stability. This only comes as a kit version, so you will have to figure out the electronics and put the plane together, since nothing comes glued or assembled from the factory. Good news is there is very little to do because this comes in a huge box, since it is pretty much a one-piece plane except for the motor nacelle covers, the fins and the canopy. Surprisingly, even that large but flat and thin box arrived undamaged and there was no shipping damage on the plane itself. Turning my attention to the build now, I came across yet another issue. The motor nacelles are designed in such a way that you either have to stuff the ESCs in a very limited space with absolutely no cooling, or have to run long wires to the inside of the plane and have the ESCs in the spot where the autopilot should go. Nowadays, stuffing some ESCs in the nacelles will not be an issue with all these small, super compact racing copter ESC options, but the lack of cooling is a major issue, and I wasn't very happy about the idea of cutting holes in the nacelles just to give it some cooling. If it needs replacing for some reason, you have to get cutting deep to remove it. So what I did was to cut out small recesses in the wings right outside of the nacelles, where I inserted a set of 30-amp Cicada ESCs, and since they are quite small, they don't obstruct airflow and don't take up much space. Motor wires were just long enough to reach through the nacelles and out to the ESCs, which saved me some effort in making them longer or cutting a shorter path. Even so, I glued only the bottom part of the motor mounts and would secure the top part of the nacelles with tape, at least for the time being, just so I can see what works and what doesn't, and still have the ability to open this up easily to make changes. Motors of choice were a set of old, in racing copter terms old, T-Motor Air 40s that I've had for a while, brand new in boxes, so I guess they found their purpose at last. Next head scratcher were the plywood pieces that were supposed to go on the inside of the plane. I was able to figure out the one for the battery, but the ones that were supposed to go in the front compartment were a mystery and made little to no sense. I glued one of them in there, and luckily the F765 was long enough to reach both ends, so I can mount it without having to resort to DIYing a solution. However, I couldn't quite figure out how the pieces for the canopy should be installed and how it is supposed to be secured in a way that would also make it easily accessible, so went with tape again. Guess I'm just too daft for this one. So, once the pondering was over, getting the electronics installed was rather quick. Not much of it. This is the beauty of the Matek Wing controllers. Absolutely love these things, so if you don't have one yet, I have some links in the description below, make sure you check them out. I used the same 4S2P lithium-ion battery I use for so many other planes now, the Zoch Dart XL, the Talon GT and the Reptile Dragon. Initially, I had no idea how this maiden flight was gonna go, so I decided not to install an FPV system to avoid breaking more gear than necessary if things went bad. And speaking of the FPV gear, I do love the nose design and how they've provided a spot to insert a servo, which in turn can rotate the camera depending on the current flying state of the plane. That nose is also designed so it would protect the camera as it is mounted more towards the inside, so in the event of a crash, the camera is not going to be the first thing that hits the ground. We'll take advantage of that later on though. Right now, I roughly guesstimated where 5 centimeters back from the wall separating battery tray and flight controller bay is, and sort of balanced the plane there, putting some dead weight in the nose, simulating the weight of the camera. 5 centimeters back from that wall came from the user manual of the old version of this plane, so I assumed it should be about right for this one as well, given that their size and proportions are very similar. Now, more details of the build will be available in my blog in a few days when I manage to put it all in writing, so you will be able to find it there. A link will be provided in the description below. Also, a VTOL tail-seater setup video for ArduPlane will be a separate video very shortly after publishing this, just so I don't water this down and make it over 30 minutes long, as it's quite long already. So, stay tuned for that. And if you haven't, please consider subscribing and hitting the bell button as well, so you can be notified when I publish it. So, with the plane all finished up, if you can call it that, and the F765 flashed and programmed, but still running pretty much default settings on most things, I went to the flying field to take care of the maiden flight. Naturally, I was going to try a vertical takeoff and test the hover mode first of all, so I didn't bother putting the extra weight in the nose during this test. Armed it, switched to Q hover and gave it some throttle, and up it went. An important point here: contrary to logic, applying the throttle slowly with this model could very well result in it leaning over and dropping to the ground, which will most likely break the props. So just raise the throttle suddenly to about 60 or 70%, maybe more, depending on your weight, and once the plane leaves the ground safely, bring it back down to about 50% to stop it from climbing. This has to happen suddenly, not slowly. So, takeoff was a fact and was successful just like that, with so little effort and so little programming done. I was actually very impressed by the ArduPlane firmware. Granted, it was sunset and the atmospheric conditions were very still, but again, it had taken no real effort in getting it hovering like this. I was genuinely surprised and impressed. Since I knew it was hovering well, I landed, reprogrammed that Q hover to Q loiter because I'm using only a 3-position switch, so it would use the GPS to maintain position, and added the weight to the nose because I was going to try and do a transition to forward flight now. That is pretty straightforward really. You switch from Q loiter to fly-by-wire A for instance, and the plane will do an automatic transition from VTOL to forward flight and hand you back control once the transition is done. The duration of the transition and the angles can be programmed, so I will cover that in the next video. And again, vertical takeoff, gained some altitude and flipped the switch, and it started to transition, and in a few seconds it was done and entered into forward flight, and I had control of it back. Keep in mind that during the transition you cannot control the plane. The weather conditions really were perfect for this sort of thing this evening, so at least I didn't have to worry about dealing with wind and a whole bunch of rocking. But even so, right after the transition, it did oscillate on the pitch axis, which is an indication that it does need tuning. I do have the control surfaces set up for maximum travel, so I would have some authority during windy conditions, giving it a chance to keep position even facing the wind full on, which I will test some other day, obviously. So that oscillation went away very quickly as I dropped the throttle and did not come back when I raised it again, so I was ready to have some fun and test the plane properly, and I have to say, this is where the real surprises started. For all of its constructive shortcomings, once in the air, flying as a plane, this was something seriously impressive. It would pick up speed so quickly and looked quick from the side, though I assume not as quick as some of you would want, but my goal has never been to fly fast or break speed records, so my idea of quick is slightly different, but either way, it was quick. Of course, as it speeds around, you can see it flapping a little bit with every twitch on the elevator. Having no spar to keep it stiff would do that. So I was very careful to keep those speed runs to a minimum and also to avoid doing any sharp maneuvers while at speed so as not to fold it in half. Dialing the throttle down was the other big surprise of the day. The plane was impressively stable in this situation, and yes, I realize I am flying in a stabilized mode, but I do tests like this for a lot of planes all the time and I know how they usually behave, and this one was an exception. Well, maybe another plane with a similar behavior at low speed is the Reptile Dragon, but again, not quite to this extent. This was seriously impressive. I could easily give it full up elevator and play with the throttle only to change the altitude and speed, and it can creep around at very low speeds, and if there is any headwind, it would even stop in one place while still being in plane mode. Such an awesome ability really increased my trust in the plane greatly, knowing it would not tip, stow and tumble to the ground. You can even do very sharp turns while flying like this, and it doesn't even twitch. Of course, I took it up higher, dropped the throttle, flew up elevator, and guess what happened? Well, nothing. It just pitches the nose down slightly and literally parachutes down gently, almost at no forward speed, and if there is some wind, that would be coming down completely vertically. No tip stow at all, which was quite satisfying to watch and experience. You can even land it this way if you run the battery too low to do a vertical landing. Well, in effect, this would be sort of a vertical landing, but it would land on the fins and the nose rather than the fins only in a vertical orientation. In fact, I did try this a few times, intentionally or not, and it does work well, to be honest. Saved the plane from damage a few times when I tried to transition a bit too low and botched it. At this point, I knew this one is going to have a great future, not because of the VTOL stuff, but because of this stow and slow speed performance, and because at this point I got complete confidence in the plane's flight characteristics, as they were stellar. This more than made up for the fact that it doesn't have a spar or that I had to install hinges myself, which is one of the things I loathe most about putting a kit together. A few flights later, just so I had time to verify those results, I installed the RunCam hybrid in the nose mounted to a Corona servo, and I even programmed it to rotate along with the plane according to the flight mode of choice. So for any of the VTOL modes, it would rotate down to a preset position within 5 seconds, which is also the time I have selected for the transition itself. So basically your view will not change much during the transition because the camera will move counter to the rotation of the plane to try and keep that same view, and I have to say that it works rather well for such a simple programming in the radio. Only thing that would have made this even better would have been for the camera to have built-in stabilization, like the GoPro cameras, at least for the HD side of things, so I do hope RunCam are listening. Another way I could have done the camera thing would be to control it via a potentiometer on the radio and manually adjust the angle after the transition, but that is just one more task I should be doing and I didn't want to have to bother with it. I assume there is a way to program such a thing in the Taranis radio, in effect mixing those two solutions into one, but I am not well versed into the more complex workings of the radio, so I have no idea how to do it. As you would expect, as wind comes along, this plane does not yield the most stable footage of them all, but it is rather light still, small, and with huge fins, and even though they help reduce the yaw shake to a degree more than other flying wings, are susceptible to moving more with the wind purely because of their much larger size. But, like I said, a stabilized camera would fix most of that shaking, but until then I assume one can try and tune a little bit, which I haven't done yet, just because I'm worried I'd ruin it. One thing I'm contemplating adding is a telefly board to make it work with my antenna tracker, as that will greatly improve the distance which I will be able to reach. Right now I was only able to get out to about 3 kilometers while trying to fly in the direction the antenna is pointed at, but it's just not the same and it is rather hard to do. Good thing about a VTOL setup is that you can literally stick that video transmitter antenna on the bottom of the plane and not worry about messing it up on every landing. Should work a treat. I did test the endurance in plane mode and got around 50 minutes with vertical takeoff and landing at the end. Did not use up the whole battery in plane mode, just so I'd have enough juice left to do a vertical landing, so only brought it down to 13 volts and then transitioned and landed. And speaking of landing this plane, any wind would make that job extremely difficult. Doing an auto vertical landing would result in disaster even in still conditions, and doing it manually is tricky even in still conditions, so I devised a new way of doing it. When it gets close to the ground, just grab it by one wing, throttle down and wait a few seconds and the motors will shut off. Simple as that, and works every time without any damage to plane or props. Trying to land it any other way would result in the occasional change of props at the very least. Trying to take off slowly as opposed to a sudden throttle burst will also sometimes result in change of props, just so you know. Now, you've heard the bad and you've heard the good and are now free to make up your own mind about this plane, but as far as I'm concerned, this one is a winner despite its initial shortcomings, most of which are only an issue during assembly, and the flying is the bit that counts, because you assemble it once but fly it a lot. And that one is a stellar flyer indeed, at least with an autopilot in a stabilized mode. I tried to fly it in manual mode with the full control surface travel. Not possible. You would have to limit control surface travel a lot to have it flying well in manual, but that would compromise all of the VTOL modes, as it sometimes needs quite a bit of deflection on the control surfaces to maintain its hover position, but I don't really mind. Not sure I'd ever want to be flying this one manually anyway. Well, you can do it, but you have to keep the motors off. Once they are spinning, it is just too sensitive to any stick inputs because of that vectored thrust it has going on. I do love it in all other situations, and even though wind does make it wobble around when hovering, not giving you the perfect hover you can see in still weather conditions, I usually spend very little time in that mode for it to matter at all. Vertical takeoff, 5 seconds of transition after that, and off I go for some distance flying, or at least I will be going once I install that telephone I bought in there. Until then, links for all items shown and used can be found in the description below, and buying literally anything through them would support this channel at no additional cost to you, and you will have my eternal gratitude as this is my full-time job. Another way you can support me is Patreon. The link is also there, and I would like to say a big thank you to all the people who have supported me so far in any way and would continue to do so. If you have enjoyed this video and found it useful, please feel free to like, share and subscribe if you haven't already, and don't forget to also hit that bell button so you can be notified when I upload a new one. Also, consider following me on Facebook. Happy and safe flying, and I will see you in the next one.